आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello students, the question here is if x is equal to summation from n is equal to 0 to pi cos to the power 2 n theta and y is equal to summation from n is equal to 0 to infinity sin to the power 2 n phi and z is equal to summation from n is equal to 0 to infinity cos to the power 2 n theta into sin to the power 2 n phi where 0 is less than theta and phi is less than pi by 2. Prove that xz plus yz minus z is equal to xy. So in this question there are relations given for x, y and z, and we have to prove that xz plus yz minus z is equal to xy, or we have to prove that xz plus yz minus z is equal to xy. If we take z common, we will get z is equal to xy upon x plus y minus y. Okay, so basically we have to prove that z is equal to xy upon x plus y minus y. Now it is given that x is equal to summation n is equal to 0 to infinity cos 2n theta, or when we expand this we will get 1 plus cos square theta plus cos 4 theta plus cos 6 theta till infinity. Now we know that this is an example of an infinite GP with first term 1 and common ratio cos square theta, and we know that the maximum value of cos square theta fluctuates between 0 to 1. So the sum of this infinite GP will be equal to a upon 1 minus r, where a is 1 and r is cos square theta. So this will be equal to, the value of x will be equal to 1 upon sin square theta. Okay. Now it is given that y is equal to summation from n is equal to 0 to infinity sin 2 to the power n phi, or when we expand this we will get 1 plus sin square phi plus sin to the power 4 phi and so on. This is again a GP, an infinite GP with first term 1 and common ratio sin square phi, and whose sum will be equal to 1 minus 1 upon 1 minus sin square phi, which will be equal to 1 upon cos square phi. Okay. Now z is given as summation from n is equal to 0 to infinity cos to the power 2 n theta into cos to the power 2 n theta into sin to the power 2 n phi. When we expand this we will get 0, or we will get 1 plus cos square theta into sin square phi plus cos 4 theta into sin 4 phi. Again this is a GP, in infinite GP with first term 1 and common ratio cos square theta into sin square phi. So its sum will be equal to 1 upon 1 minus cos square theta into sin square phi. Now we have to prove that z is equal to xy upon x plus y minus y. Okay. Now we will try to find out the value of xy upon x plus y minus 1, where x is equal to 1 upon sin square theta, y is equal to 1 upon cos square phi. Okay, so putting these value here, we will get our expression as this. Okay, upon simplifying this, we will get 1 minus numerator as 1 upon sin square theta into cos square phi, and the denominator will be equal to cos square phi plus sin square theta minus cos square theta into sin square phi, cos square phi into cos square phi will be here, not cos square phi into sin square theta upon sin square theta into cos square phi. Now the cos square phi and sin square theta will get cancelled out from numerator and denominator, and we will be left with 1 minus cos square theta. We will be left with 1 minus 1 upon this cos square phi minus sin plus sin square theta minus cos square phi into sin square theta. Now what we will do, we will put 1 minus sin square phi in place of cos square phi, and 1 minus cos square theta in place of sin square theta everywhere. Okay, so that we will get our required answer. When we multiply these terms in the denominator and solve, we will get 1 minus sin square phi, or 2 minus sin square phi minus cos square theta minus 1 plus sin square phi plus cos square theta minus sin square phi into cos square theta. Okay, and upon simplifying this whole term, we will get 1 upon 1 minus cos square theta into sin square phi, which is equal to z. Okay, now we are able to prove that z is equal to xy upon x plus y minus 1 for the given values of x, y and z. I hope this has answered your question and your doubt is clear. Thank you.
क्लास 6 से 12 से लेके नीट, IIT, जेईई मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।